All right, we're going to continue graphing using f prime, and f double prime. We're just going to have a little bit more fun with it. So at the end of this lesson, you will once again be able to use information about f double prime, and f prime to analyze graphs. All right, this is a very popular, and actually I think I took it right straight from the AP test. So this would be a very popular type that you just might see. So we're going to let f be a function defined on the closed interval from -3 to 5. The graph of f prime is shown, and so we're going to use the graph to actually answer these questions. So you'll notice for part A and for part B, I'm just going to read through them quickly. On what intervals, if any, is f decreasing? And find the x-coordinates of each relative maximum. Well, I know both of those. I usually do the first derivative test, or the f prime test, to find that information out. So what I would like to do, I know it's very easy to answer that information if I have an f prime chart. So that's exactly what I'm going to draw, is an f prime chart. Okay, since this is f prime, I know critical numbers are just where f prime is equal to 0, or where f prime is undefined. So it's going to be at that spot, this spot, and this spot right here. So if I'm looking at this, my f prime is undefined at x equals -2, my f prime is 0 at 2, and my f prime is 0 at 4. Okay, so now before that, before -2, I notice that all of my derivative values are positive y values. Between -2 and 2, I also notice that all of my y values are positive. Between 2 and 4, I notice that my y values are negative. And after 4, I notice that all of my y values are positive. Okay, as soon as I have my chart, I'm pretty much done with my work. Now I just have to analyze it. We learned in a previous video that if I'm looking for decreasing, I'm basically just looking for where is f prime negative. So if I'm looking at this chart right here, there's only one interval where f prime is negative, and that is on the interval 2 to 4. Notice I'm not including brackets because at 4 and at 2 the derivative actually equals 0. So on what intervals, if any, is f decreasing? It would just be the interval 2 to 4. And then it does say to justify your answer using a because statement. And so this will be because, if I looked at my chart, I basically can just say because f prime is negative. That's why it is decreasing. Okay, the next part just says to find the x-coordinates of each relative maximum. So we know that a relative maximum occurs when f prime changes from positive to negative. So if I'm looking, this one changes from positive to positive. Nope. This one changes from positive to negative, so this definitely work. And this one changes from negative to positive, so that one's actually a minimum. So if it asked me for a relative maximum, I would say x equals 2 is a relative maximum, and then it does say to justify my answer using a because statement. This is simply because f prime changes from positive to negative. Okay, so if you can get that chart, you're home free, because you'll be able to answer the question very easily. All right, let's look at C and D. This time it says on what intervals, if any, is f concave up? And then for D, find the x-coordinate of each point of inflection. Well, I know when I'm talking about concavity and points of inflection, I'm talking about f double prime. So if I have a f double prime chart, I know that I can answer those questions very easily. All right, we're at f prime right now. If I'm talking about f double prime, that's the slope of f prime. So if I'm looking at the slopes, I'm looking at the slopes of the tangent lines. That's how I'm going to get my chart. Okay, I notice that the slopes of the tangent lines are going to be negative until I hit -2. Okay, from -2 till I get up to 0, my slopes will be positive. After 0, actually all the way until I get to x equals 3, the slopes of my tangent lines will be negative. And then after 3, actually all the way to the endpoint of my interval, my slopes will be positive. Okay, once I've analyzed that, I'm pretty much done. Now I can just use my chart to get my answer. We learned in a previous video that if f is concave up, the second derivative will be positive. So when it's asking for concave up, if I'm looking at my chart, that will be from -2 to 0. And then again from 3, I'm not actually going to go to infinity because I know my chart ends at 5. So we'll just put from 3 to 5. So from here, and I could do brackets there, I guess, to close it. I'm not going to be real picky about that. And why is that concave up? That's because f double prime is positive. Notice I really don't have to get too much of it into an explanation. As soon as I have my f double prime chart, I can refer directly to that chart. Okay, points of inflection, we did learn in a previous video also that points of inflection occur where f double prime changes sign. So you'll notice that x equals -2, x equals 0, and x equals 3, f double prime changes sign. So we can say there are points of inflection at x equals -2, at 0, and at 3, and that is because f double prime changes sign. So these problems kind of look scary when you start, but hopefully you notice that they're really not so bad at all.